What is the likelihood of getting 3 sixes in a roll of dice? What is the chance of getting 4 aces in distribution of playing cards? What is the chance of your material getting accepted by the client's sampling plan? Answers to these questions lies in the understanding of the probability concepts.
Welcome to this course on probability. These are the topics covered in this module.
If an event is certain to happen, then the probability of the event is 1. If an event is certain not to happen, then the probability of the event is 0. If it is uncertain whether or not an event will happen, then its probability is some fraction between 0 and 1. If you toss a coin, the probability of getting a head or a tail is 0.5. Since there are only 2 possibilities, and both possibilities have equal chance. Similarly, when you roll a dice, the probability of getting a specific number is 1 divided by 6. Let's now look at the compound events, where more than one events occur. In this case, let's assume we have 2 events, A and B. These events are said to be mutually exclusive if they cannot occur simultaneously. For example, if you toss a coin, you either get a head or a tail. There is no possibility that you may get both. So getting a head or a tail, in toss of a coin, are mutually exclusive. In that case, the addition rule can be applied to it. So once again, addition rule applies only to the mutually exclusive events. Events are mutually exclusive if they cannot occur simultaneously. If events are mutually exclusive, as shown in the left, the probability of A or B will be the sum of their individual probabilities. But if events are not mutually exclusive, as shown in the right, the probability of A and B gets added twice. This is the common area between A and B, so in that case, we will have to subtract the probability of A and B from the sum of 2 probabilities. If A and B are independent events, then the chance of event A occurring does not affect the chance of event B occurring, and vice versa. For example, 2 rolls of a fair die are independent events. The outcome of the first roll does not change the probability for the outcome of the second roll. In case of independent events, the probability of events A and B is the multiplication of their individual probabilities. If we flip a coin, the probability of getting a head or a tail is 0.5. If we flip 2 coins, then the chance of getting a head or a tail for 1 coin does not affect the same for the second coin. So the probability of getting 2 heads, for example, is 0.5 times 0.5, and that is 0.25. Acceptance sampling is a common quality management technique. Sampling may be done with replacement or without replacement. In case of the sampling with replacement, each member of a population is replaced after it is picked, then that member has the possibility of being chosen more than once. When sampling is done with replacement, then events are considered to be independent, meaning the result of the first pick will not change the probabilities for the second. However, in case of the sampling without replacement, each member of a population may be chosen only once. In this case, the probabilities for the second pick are affected by the result of the first pick. The events are considered to be dependent or not independent. To find the probability of 2 independent events that occur in sequence, find the probability of each event occurring separately, and then multiply the probabilities. When events are dependent, each possible outcome is related to the other. Given 2 events A and B, the probability of obtaining both A and B is the product of the probability of obtaining one of the events times the conditional probability of obtaining the other event, given the first event has already occurred. A probability distribution function gives the relationship between the variable and its probability. the probability that x can take a specific value, is represented by px. For the sake of simplicity, in the next few slides, we will be covering the discrete variables only. Discrete variables are the variables which can have discrete values. The other type of variables could be the continuous variables, and we are not covering those in this presentation. For example, if you roll a dice, and there are 6 possible outcomes, each of which occur with probability 1/6. In the graph on the right, we have placed the outcomes on the horizontal axis, and the probability of each outcome on the vertical axis. Instead of 1 dice, this time let's roll a pair of dices. The sum of 2 numbers, and their probability is tabulated on this slide. For example, the probability of getting 1 on a pair of dice is 0 divided by 36. Since it is not possible to get the sum as 1 when we roll 2 dices. On the next slide, we will show this data in the form of a discrete probability distribution. We have drawn the data on the previous slide in the form of a distribution. The horizontal axis shows the outcome of rolling a pair of dices, and the vertical axis shows the probability. This distribution can be used to answer a number of questions. For example, what is the probability of getting 5 or 6, as shown above? Look at the data classification chart, shown here. This chart is taken from the Basic Statistics course, available on this site. The examples we have been discussing so far were related to the discrete data, the data where we count the numbers. Thanks for attending this course. In the next course, we will look at the various types of probability distributions,